Hey guys, it's Vince. Today in this video, I'm continuing with my G540 build, and it just so happens, and this happens quite a bit, as I'll be building to basically back build for inventory. I like to keep one system on the shelf ready to go, and it's just usually a base G540 system. I don't usually have more than that on the shelf because naturally it costs more money to back build inventory. Put it on the shelf, it costs you more money. Therefore, as I was building, I actually sold the system I was working on. Now, that being said, the same build I was working on is right here as far as the power supply and the fan, but you'll notice this client wanted the Master Edition enclosure. And I get asked all the time, what is the difference between the Master Edition enclosure? Well, the difference is that your GX16s are all put into the rear of the enclosure so that it will support all of the G540's inputs and outputs. And in this case, we have 4 inputs that are GX16 3-pin panel mount. You can see them right there. They do come with the dust covers, which also protect against any potential risk of contacting those pins. So these are not just dust covers, they also keep any type of metal objects out of the way that could actually short out your inputs. That being said, this panel also comes with one GX16 6-pin panel mount, which would be for relay control as far as for spindle manipulation, as well as PWM control. Now on this side also, we have another GX16 3-pin if somebody was to install another relay, let's say for a plasma system, or to have another relay installed for cycling direction fore and aft, which you've seen in previous videos. In that case, we would have to decide how we want to do that. We could either use the 6-pin or we would use a 3-pin in conjunction with the 6-pin. Typically, you'd use a 6-pin, but either way, this enclosure is set up so that all of the harder work is done. And you can see right in the back how we have all of our clearance. And look at how short the wire runs are going to the drive. Okay, the longest wire runs are right here. And again, we would use a ferrite with proper filtering as far as the frequency in order to eliminate any potential EMI for passive filtration. This right here is without a doubt the best investment for anyone wanting to eliminate any type of work moving forward. Let me explain. This client, you notice none of these are wired. This client wanted this in case he decides to add any other accessories that the G540 supports. I always tell you guys, check out using soft limits first before putting in physical switches. If you get the results you want with soft limits, guess what? You saved all of that money. However, if you decide that you want to put in physical switches or a touch plate or whatever other accessories the G540 supports, guess what? All of these ports are set, so you're good to go. This is why paying attention and having a consultation with me pays for itself, because this client then doesn't have to worry about machining a standard backplate because all of the work is already done. Again, paying attention to detail is everything with engineering, everything. So I'm going to finish assembling this system because there's no reason for me to work on a system that isn't sold already. I'll get this front and back plate out of the way. This is the one that was originally mounted on this base plate with the power supply. And then I'll have room to continue. You'll notice I have my power leads that are silicone 18 gauge for our G540. Another key point you're going to notice, all of my 540 systems come with a terminal block allocation sticker. 1 through 4 are your inputs, 5 and 6 are your 2 outputs, 7, 8, and 9 control your VFD. If the client decided to do that, that would be once again for PWM manipulation for 0 to 10 volts, equivalating to 0 RPM all the way to 100% RPM. And then of course, 10 is E-stop, 11 and 12 are our power leads right here. And that's it. There is no confusion. One half of the cooling system is here, which again, we're extending the mass of the G540 with thermal adhesive using heat sinks. And then we have our cooling fan. So once this mounts, this will naturally have the cooling fan blowing right over our fins. You can see exactly what we're doing. Very simple. First thing we're going to do is grab our deoxit. And we'll come over here. I'm going to knock out hitting our terminals for our client. And then we'll be prepped so that we can get this system where it needs to be. Now he's protected. Proper screwdriver. Once again, there's no guesswork. If you guys are servicing your system yourself, if I don't know, for instance, where my black lead would go for V negative power input to the G540, I can just refer to that terminal block sticker. Come in here once again. You notice I'm using a flathead screwdriver. Why is that? You know what flatheads are used for, guys? Low torque screws. Flathead. You don't need to use a Phillips on any of these. Now, I already know from checking the reference point on that G540 allocation sticker where everything goes. And the next pin is pin 10, which will be for our e-stop. So now what I'm going to do, stand up, move this over. Okay. Get our e-stop in. Come right in here. And the same way I'm servicing this right now, it's for assembly, is the same way I would hope my clients would service it if they were going to work on their own system. I always do a slight pull check on the leads, make sure everything is seated. Nice. Now again, these leads are naturally not going to be under any resistance. The main thing is that you're making sure that that screw is tightened down to at least make contact. Now what we're going to do, we got our 2 power leads here. I'm going to come over here, these out of the way. We will lay this down on this end, just like this. And I will come in here. And we will apply a little bit of deoxit to the leads. Okay. Fish that guy underneath. And then we'll go right there. So whenever you guys see flathead screws, just tip, you know that that's a low torque screw. So in electronics, most of the time, you're going to deal with low torque screws. Very, very few screws in electronics, if any, would be considered high torque screws. And that being said, you don't need to murder the terminal when you're tightening down anything. Right in. Once again, very simple to follow the allocation sticker on the power supply. V positive terminals are in the back, V negative terminals are in the front. Everything here is set. Pitch forward. Fold everything in. Silicone will work with you very easily. And we're right there. So you can see how this is falling together. Now we're going to do our ground. Ground lead, same principle. And this already has deoxit on this terminal. Of course, I'm going to change my screwdriver real quick. And I'll come over here with this. Switching over to torque now. Done. Now, some of you may be asking, why didn't I use a torque screwdriver on the smaller terminal block screws for power output? And that's because this is too much torque for that. So again, logic comes into play. I would be better off doing it by hand, just much less tension. And again, that's just basically understanding working with this type of hardware. If you've never worked with it, less is more, and always work with that. Okay, and you can always do the pull test. Like I said, pull test. If it feels seated, you're good. If there's no tension on anything, then there's no reason to tighten down anything ridiculous. When you're working on a vehicle or another type of machine, the reason you tighten down bolts the way most people do is because you're either dealing with vibration or it's under tension, in which case that's required. Working with electronics, it's not. So we're going to come over here now. You can see the entire system is built. All we have to do is tie everything. I want you to think about now what I just said. When you consider the fact that this is a 4-axis integrated stepper drive system. So all 4 drives are already wired. Power supply is already wired, front and back plates wired. He's even got the accessory plate in the back with all the options to add whatever he'd like. Now what I'm doing, clean up, grab our Phillips, and we're going to come over here, 2/4 inch, 6/32. Here we go. Okay. Come over here, we'll center it as best we can. So it looks kind of busy and like a mess. Be transformed shortly. Right here. Beautiful. Good. Good. I always do this, like I said, about 2 or 3 times just to make sure I get everything in perfect alignment, as much best alignment as possible, just doing a field test. That's just me. Do one more. And I think right now, feeling good. Beautiful. Okay, now what I do is I'm going to come over here and I like to sight in on the enclosure just to make sure that my leads are not under stress. Of course they're not. And I just take a probe and come in here and kind of fold the leads down, because in this case we're dealing with silicone, and silicone will move out of the way very easily. You don't have to do too much. Just touch, move, and manipulate. Done. You notice our e-stop cable out of the way. Everything there, beautiful. Nothing is under stress, and that's exactly what we want. Now, we're going to take this with our zip ties and clean everything. And this is where that careful planning and understanding what length leads you need really brings everything to fruition, because your presentation to me is everything, not just for serviceability, but this is what defines that you've done your homework on how your layout is going to be for your enclosure. Now, you'll see a lot of guys using cable guides. If you want to use a cable guide, that's totally up to you. I don't like them personally. They're a lot of work when you're dealing with servicing. And the guys that use them forget about servicing. They seem to want to make things more permanent in their system. Not smart. You want to be able to service your system on the fly. The faster you can do that, the faster you can keep running. Guys forget that. At least the YouTubers I've seen, most of them want to make things real permanent. When you make things permanent, you have problems. Simple is best under most pretenses. Robotics, if you've done it for a while, you understand, many of you are shaking your head because you do understand it, that the idea is to have it permanent to the sense that we are wanting neatness, not permanent in the sense that we cannot service or adjust. If you do that and you work at that capacity, you're going to find life's a lot easier. See what we're doing here? Very, very simple. Main thing is to make sure my leads are out of the way, because I have tied myself in a corner a couple times, but that's where, once again, whatever you're doing, just like whatever you guys do, that's where your experience comes in. Those mistakes are not mistakes, they're a learning curve. And the more you adjust to that learning curve, you adapt and overcome, right? Like the military. And that's exactly what you're supposed to do. Learn. Never stop learning. Test everything. Believe nothing. Very simple. Very simple. There you go. Okay, see everything getting now pretty much where we want it. Coming in, I try to center everything. Once I get everything in its place, I'll show you what we'll do. Well, actually, you know what? We'll trim these now. This way, clean this up a little bit. Starting to look like a system, isn't it, gentlemen? Done. Same process. Usually when I'm tying, I like to stay with a wire tie first, meaning wherever the hold down is, I'll actually tack it with that first. Leave a little slack in here because these leads can be adjusted then. And nice. Now you'll notice these leads, and you guys will go through this yourselves. These are not silicone. These are just straight up 16 gauge leads. And when they come from the fuse or wherever you're working with, if you find that you are working with PVC type leads, you're going to find that they're not always as flexible as you may like. That being said, many of you already know the answer of how we correct that. The word is heat. We do this very carefully. Never hit anything sensitive, just hit the conductors themselves. And that allows a molding effect. So now I can come in here and these leads that used to be tight are no longer tight. I can mold them any way I'd like, and there's no stress. And this is why I say time and time again, an integrated drive system built correctly is beating virtually every other system on the market, mainly, if not for anything, simplicity. And then on top of that, you have the luxury of servicing the system very quickly, very, very quickly. Come in, do final heating on this then. Right there. We're golden. That's beautiful. Okay. And you'll notice the leads still want to fight me a little bit, no worries. Be very cautious when you use your flush cutters that you do not cut, God forbid, a line. I've had clients tell me they've done that and they're moving really quick or they're working late at night. I tell you guys all the time, do not work when you're tired. Not best practice. Hey guys, jump over to eDealers Direct Automation and check out my eBay store for the components used to make what you see in this video, as well as many others that you may not even realize you need. Of course, I'm always there if you have questions. Message me and I'll get back to you as soon as possible. And of course, I do custom engineering as well as consultations. Thank you for watching this video and your support. Take care. Done. Now, get everything basically where you want it. Now I go precision heat because now everything's tied. That, in fact, you don't need a lot of heat. You really just need them areas that you want to concentrate on. Perfect. That's us, boys and girls. We're golden. Yeah, one more up here. Take it. There we go. I want you to go online, do some research, and see how many 4-axis systems are wired that fast and tied to this level and cleaned in that speed. This is all real time. Think about what I just showed you. Yeah. Golden. And now and then you get one that just sticks up. It doesn't want to be friendly. Okay. Clean everything up. And we're golden. Okay. Now we're all tied. Now for the next step, I'm just going to get my desk cleaned and it will be graphical time. So final step on this is graphics power testing, and that's it. Right, guys, I've just gotten done putting on all of our servicing graphics. Once again, these are not put on just for show. These are put on to, once again, help the client. Clean fan biweekly for optimal cooling for performance. Once again, I have certain clients that do that. I have other guys that I'm sure don't. I'm not putting this on there for my health. Believe me, I'm doing extra work doing that. It's costing me money. The reason I'm telling you to do that is to make sure that, once again, that fan does not ever get clogged with sawdust and other types of debris, dust, so on and so forth. Please review the user's manual and all email supplied videos prior to the system's operation. Naturally, that's self-explanatory. Read and review every piece of documentation, whether it be a video or documents that, once again, pertain to the operation of your controller. Spin it around. Once again, Gecko drive information, you've got it here. We've got it on our power supply. Main USA quality validated. Once again, we're going to go through this. I'm going to plug it in now. We'll do a full power test on it. We've already done a grounding test. IEC cord coming out of our soldering station. And I just go over everything for sanity. Sanity check, live neutral ground. Take nothing for granted, and that includes myself. And we're perfect. Looking good. And that's on. And I'll let her come over here. You hear our soft start fan? Green light, disengage fault. Disengage fault. And I do this a couple times to make sure everything is set. Okay. Power LED on the power supply. Not really necessary when we get a fan kicking that much in and out. Multimeter goes on. Switch my leads underneath. Checking voltage now. That's perfect. I always calibrate mine to 48.5 with golden there. I've already tested this power supply beforehand. I just do a quick test on all reads, just making sure everything is good and nothing has changed. Cool. Checking grounded. Once again, power on. Perfect rounding. Everything looks great. Switching over now to 110 so we can check our auxiliary. And that's it. Now she's fully tested, LED in the front, everything here is functioning as it should. We'll check e-stop one more time. We're perfect. And that's it, guys. Now, of course, this is still a base G540 system in that none of the accessory ports are connected. In the event you were to order this system and you wanted me to wire in all the accessory ports, well, naturally the price goes up because labor goes up. So keep that in mind. Other than that, this system's set. And if you guys are competent enough and you feel that you're okay doing the labor on your end, you can certainly do this like this particular client in the sense that buy the system in this format with all the ports added and add whatever accessories you want, saving all that money in time and labor. So this, once again, has been a really detailed video. I hope you guys have gotten a lot from it. And once again, you get to see exactly how these are built. And you can see what you're left with. Not much. This system is set to go. And best of all, it will take that client from wherever he wants to go and allow him to, once again, add relays, add input should he decide to, and whatever other accessory the G540 supports. And best of all he has to do is invest his own time and, once again, labor, because he will be getting the matching female connectors with these ports as well. That's something I always do. I don't charge you guys for that. If you buy the master edition version, or in this case, this is just the enclosure that's considered to have all ports added, and that's exactly what this is. He will receive the matching female GX16 3-pin connectors with this. So he doesn't even have to source them. All he has to do is build whatever cables he requires for whatever accessories he wants to work with. So again, guys, I hope that this video series has been helpful. I hope you guys have learned a lot. And once again, there's no more smoke and mirrors. You got to see the whole process of me doing this right there in front of you, and you see what we're left with. So I'm going to get to boxing this up, putting a lid on and all that. Now, of course, I go and film a video for the client as well. In this particular instance, I could actually just send him this video and we're set because power test and grounding test, everything has been done just as I do for every system. So once again, hand-built systems all the way through and through, from, once again, building the e-stop cable, shielding it, to actually testing and confirming each component individually, as every system should be built. I don't care what brand you buy or who you buy it from. This is the process that should be done. And that includes validating grounding and every other port that's on the system that needs to be done. So keep that all in mind. Thank you all for your support. Take care.